Hi everyone, my name is Kaushal. So today I am going to discuss about the Kubernetes self-healing and scaling the experiment. I will show the demo of the self-healing and scaling experiment. For that I have made a project. So first of all I would like to give the review of the project what I have made. This will give the explanation of the self-healing, horizontal scaling, declarative infrastructure, reconciliation loops. So we use the fast API, Docker, and kind Kubernetes. So overall architecture is this: user hit will on this IP, it goes to the node port, and node port internally maps to the service which is running on the 80th port. After service, it will go to the Kubernetes cluster. In this cluster, there is a one control panel and two working nodes. Working nodes are running on 8000 ports. So this is the overall architecture. For that, I have made the applications. We use the fast API. In this fast API, we made the two endpoints. One is providing the pod information, and second is providing the health of that particular pod. And this is deployment .byml. In this byml, we have provided the different tags, and the most important tags is the replica is equal to 3. So whenever I up the application, the minimum three pods will be running for that projects. And next is the service. So how traffic flow, as I already told you, outside what hit on this port, it goes to node port which is mapped in the kind config, and after kind config it will go to the service port which is running on the 80th port, and after that it will select the pod will be running the 8000 port. Request come from this port, node port forward to the service port 80th, and service will forward to the port with the app name who am I, and after that traffic goes to the pod target port. Now what is the self-healing? This is the concepts that I have to elaborate. So self-healing means whenever for any reason, suppose there is an initial state of replica of three pods are running, for any situation any pod crashes, so Kubernetes will take care of this thing. Whenever any pod crashes, it automatically detect with this reconciliation loop. So we have defined the replica set is equal to 3 here. It means that this is the desired states, minimum 3 is required, and it automatically runs by the controller replica set and compare the how many pods are running. If any discrepancy, it will create or delete the pod, and mismatch will be gone, and at any point of time the desired and current status will be the equal. So this mechanism is called that the self-healing, always heal itself, and this is a reconciliation loop which will run continuously by the controller. And now comes to the horizontal scaling. What do you mean by horizontal scaling? Horizontal scaling means that whenever the load increases to the system and you want to increase the pod, so yes, we can do with the coordinator very easily by just execute the simple one command, kubectl scale deployment who am I replica is equal to 5. Now the 3 pods has been replicated and created to 2 more pods. In the same manner, whenever we want to scale down, this replica is equal to 2, from 5 to 2 it will scale down. And now next term is the declarative infrastructure. What does it mean? Declarative infrastructure means, so in ByML, declarative.yml, this is the source of truth. So replica is 3. So whenever you run the kubectl apply -f deployment.yml file, so cluster reconcile to match the ByML desired is equal to 3, so, and replica set ensure the 3 pods. So whenever we execute this command, so 3 replica will be created. Now whenever we execute another command called the kubectl scat deployment whomi replica is equal to 5, now 5 clusters are up. So it means that drift exists. ByML replica is 3 and cluster replica is equal to 5. So this is the drifting. Now I already told the different concepts: desired states, current states, replica sets, self-healing mechanism, horizontal scaling, and declarative infrastructure. Means we declare here that many type of pod will be running when I apply, when we execute the apply command, and we want to increase the replica. Yes, we can do by using this command scale deployment whomi replica is equal to 5. This is again the simple way of the project execution flow. First of all, it will create the cluster. Second, it will create the Docker image of our projects. After that, it will load the image into the kind cluster, and after that we apply the deployment.yml, again service.yml, and pod starts ready and application access. And we do the following experiments, means watch the traffic, delete app, observe the self-healing, scale up, scale down, and apply the YML file back to the 3. And these are the term key concept summary. Means pod means smallest deployable units. It will run on your container. Label key value pair used to group and select the resources type. Replica set ensure the right number of the pods are running. And deployment, it will manage the replica sets, provide the updates and rollback. Service stable endpoint to access the set of the pod. Whatever the part, there will be the one endpoint. From that endpoint, the pod will be accessible. And readiness proof determine if pod is ready to receive the traffic. Liveliness proof determine if the pod is alive and restart if it failed. Node port expose the service on a port on each node. Desired states, whatever you want. Current state, what is actually running right now. Self healing, it restores the desired states automatically. Horizontal scaling increase or decrease the number of pods. So this is the overall flow of my projects, and apart from I have defined the different concepts. Now comes to the experiment part. First of all, I am going to create a cluster. Whatever the command for the setter I have write down in this file. First of all, it will create the kind cluster. Paste here and just hit enter. I think Docker is not running. 1 second. Docker is running or not. Okay, Docker is not running. Docker is running. Why it is not running? 1 second. Have a patience. No. Okay, fine. Now Docker is up. Now it is creating the image. It is showing. Why it is not showing? So now it is creating the cluster, name the Kaushal, and creating the image, preparing the nodes, writing. Now starting the control plane. Now Docker is running now. You can see the process. 1 second. Now I can see the Docker is running now. Now comes to the next point. We created the new image called the Docker build -t, and this is the image of my project which contains this main.py file. And in this main.py file, I have defined the fast API which has two endpoints, slash and slash health chat. It will give the port name and it will give the status of that port name. Now the Docker image of this project has been created because I have provided a Docker file for this project. You can see here, and I write down all the command that requires. Means first of all, it will download the Python slim file, go to the working directory, and after copy the requirement type, and it will install. And after that main.py will be the copy, and again run this command and it will expose on 8000 port number. Now comes to the, after getting the image, we can, we should load the image into the kind Kuberneters. So this is the command. The name of the cluster is the Kaushal, so it will create it inside the this Kaushal cluster. So our image is going to loading inside the causal cluster. After that, I am going to apply the deployment.pyml. In this file, I have written the main thing is a replica is equal to 3. So it will create the 3 pods, and all other the kind is deployment, meta tag. It is the definition of different tags that I will explain in some other projects. Let me finish the experiment first. And this is the kind cluster. Cluster definition means a type of cluster is a client, and three pods will be created. One will act as a control panel. At this for this is from the outside world on the 3040 port number, and container of this cluster will be the 3080. Now comes to the next command. And service environment. Service environment. This what it is written. Service environment. Yes, kind of the service is this. Name is this, and this service available at port number 80, and this is the target port from where the this port number will communicate to this here, and this port is available for the public. I already told the flow means from the public. Suppose IP port number is 100, and from 100 it will come inside here, and this will communicate to this service by this port number, and service will be available here, and after service it goes to the pod which are running on 8080. Now comes to the next command. Now it is a rule loud status. What is the status of loud? Now it is successfully done, and you can see here the number of ports is there, and you can also hit the on API. Yes, it is running and showing the status of port name is this. Now comes to the experiment. Now comes to the experiment. How can I do the experiment? First of all, I am going to running this command in this screen. So it will show the 3 ports are running and all the information. Now I am going to terminate one pod here. So first of all, we execute this command. 3 out of 3 is ready. These are the 3 ports. And this is a replica set of 3. Now I am going to delete this J5RNN. control, and just say here it will delete and automatically increase one more pod. So kubectl delete paste. Yeah, what happens? Kubectl delete pod. Okay. pod space. Now just say here terminating pending container creating running. Now you can also say with the help of again. Now again the 3 pods are running. Now one thing you can watch that this container which I have deleted, which is the in last 5 RNN, it is not available anywhere. So whenever the pod is deleted, it will create a new pod. And now I am going to scaling up. Suppose load increases and I want to scale from 3 to 5. Yes, we can easily do with the help of kubectl deployment and name of the cluster, after that container, and replica is equal to 5. Now here you can see that creating and started running, and we can also check from here. Yes, you can check the 5 pods are available. In the same manner we can also scale down. Two. Now 3 will be terminated and now it will be show only the 2. So this is the horizontal scaling and also downing the this one. Now next one is that if we do this command and inside a deployment by ML we have set the replica is equal to 3. Now it will create the 3 clusters because already 2 is already and one more will be created also. So you can see here, yes, now 3 is created and 2 will be available already T7 and DJ, and this will create the new. So this is the overall experiment that I demonstrated you. Hope you people like it. Have a good day. Bye. Thank you.